Is there an echo? Is there an echo? All right.
So I thought I'd done this before, but when I just looked for it, I realized I hadn't.
So if you have a presentation for your group presentation, I just made a thing in the assignments for today where you can upload the file or a link. And that way we can quickly switch between groups by just selecting the next one on the computer up here. So if you could do that now while we get ready to start,
that would be great. And I just want to take this thing out of my ear. Just want to go through sort of the process of the quizzes and everything. It makes sense to me if you do the quiz while you're watching the people do their presentation. The quiz where you ask a question of them and where you give them some feedback, so that you don't have to go back and watch the video of the class again, right? If you do it right now, then it's done and you don't have to worry about it again. And later, if you can't do it right now for whatever reason, then you'll want to make sure that whatever your feedback, your comment is pertinent. It's not just the fact of putting an answer in the box. We'll consider the quality of your answer in assessing the grade for that. So if your comment or your feedback is good job, it's probably not full credit. It's better than not answering. But you did a really good job because you thoroughly considered blah, 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 or whatever. Then that makes more sense. I will be doing the same as we go through the slides. Let me see, we got 4 groups, right? And all 4 of you have put something in here. So I think we're about ready to get started. I just want to make sure that the screen capture and everything is actually working on YouTube. Make sure that we actually get a record of the class. What order should we go? 1, 2, 3, 4? 1, 2, 3, 4? Okay. Sounds good to me. So that's what I work. All right, it picks up me. Here, this mic works too. So if you talk in or around this mic, it should get you. All right, I'm going to sit down on one of these tables. And group 1, you guys are good to go. You can full screen that or whatever. And I think I would talk close to the mic, yeah.
Should we just stand over and have one person stand in front of the lectern?
Yeah. And you don't all have to stand up to present?
We all have a part to talk. So
Okay, that's perfect. There's no requirement that everybody does it.
Why no work? Shit. All right, so we're team 1. We did electrical discharge machine, EDM. And what is EDM? It's basically a subtractive manufacturing method that uses electrical discharges or sparks to form the features.
These parts must be made out of electrically conductive material, or else this won't work. And there's two types: there's die sync EDM and wire cutting EDM, which right here, die sync is also known as conventional or sinker EDM, and it's done by removing material from the mold using a graphite electrode, and there's this dielectric fluid between the cathode and the workpiece, and it basically just it sparks as it's going over the piece, and it erodes the material as it's going by. Here's a little example of that. And then wire cut EDM, it also removes the material, obviously using EDM, has a wire acting as a cathode, and it's this taut wire that is like, as you can see, it goes like up and down between the workpiece, and it's used to cut out like the workpiece. The wire is guided along the cut path, and it cuts the piece. It also uses a dielectric fluid to keep these sparks like extra precise, and the wire does not get reused.
All right, so I'm going to talk through a couple of pros and cons. Most of these are focused on wire EDM because that's kind of where a lot of our actual machining is going to be for our actual part with the gear. But some pros is that you can cut pretty complex shapes or really small shapes. So part of cutting with a wire rather than conventional tooling is like you're not dealing with having a tool with a radius or like a specific way it cuts. So presumably for a mill, right, you can't cut an inside sharp corner very easily because you have the radius of the tool itself. Whereas for this, a tiny tapered hole, gear teeth, for us, the hex bore, all those shapes we're capable of doing with the wire EDM to a different level of precision, and tiny just because the actual size of the cutting implement, right, the wire. And for us, the gear teeth, we're doing involute cut teeth, so it's a pretty complicated shape. Also cutting very hard materials, so obviously they have to be conductive, as we mentioned, but we're going to be using steel. We're not going to have the same limitations necessarily for hardness that we would if we were trying to cut with an end mill. And maintaining very fine tolerances. So I have a GIF on the right that I think is kind of cool. If you look up examples of people using a wire EDM, there's like a toy that people make a lot where they'll do two complicated shapes that are really close to each other. So there's like a nice running fit and they slide into each other. So I think that's kind of an illustrative example of how fine of a tolerance you can get. Between two different parts, you can get them where they just slip in smooth like butter. Some actual cons is that there is a inherent skill set needed for operation. We've already had a fairly steep learning curve, just kind of getting to the point of understanding what we're doing, safety, setting up cam, et cetera. And because we're at a school, there's people who are experts who work with these machines. But if you're actually using this in industry, you might have a different kind of, bringing in a machinist who has only used conventional machining, there's still an inherent larger skill floor to get into. There's also slow material removal. So you are going to be cutting at least at a moderate pace to get like the tolerancing that you want and the features you want. And then the last one, which maybe is less obvious, is that there is an overcut. So with most conventional tooling, you're going to be cutting the size of the tool most of the time unless you're deflecting. For the wire EDM, every time that you make a cut, there's going to be a slight overcut because the sparking of the wire itself is going to increase the size that you actually cut your part out with. That's something that is like somewhat linear, at least from what we found. That's something that we have like an understanding of, so you can prepare for that, but still like you can't cut like the size that you cut is still slightly larger because of that spark.
So moving on to how the EDM applies to our project is, in the machines that we are using for the project. So we're going to be starting by using the Haas mini mill, which I think most of us are familiar with or have used in ME1800. It has a pretty big travel distance. It can hold a decent bit of weight, and it cuts relatively quickly. And you can see it moving pretty quickly when we've used it in the machine shop in Washburn. And so the main purpose for using the mini mill is that we are going to be pre-cutting a hole so that the EDM can then do the hex key in the center of our gear, and then we're going to be facing our stock so that it looks good. Moving on to the actual EDM, as Justin and Sam mentioned earlier, we are really using the wire EDM, and it has lots of benefits, such as the precision. It does have about the same travel distance as our Haas mini mills. It can hold a lot more weight, but as Sam was mentioning, it moves at a much slower rate. As you can see here, it moves at around 40 inches per second as opposed to 500 inches per second on the mini mill. And we're using our wire EDM to cut the center hex and our complex tooth profile just to make sure that we are getting that nice, precise cut.
So I'm gonna talk about the machine operation we're gonna be doing. So on the top left corner, you're gonna see the drawing of our part. The center hex is the running fit. I think we're using RC7 from the machiner's handbook. This zero tolerance are grouped into fine zero tolerance. I don't remember what it is. So there are 4 operations you're gonna do. First, you want to face a deer surface. You're gonna put in either a mini mill or VM or whichever mill you want to. Then use a face mill to do both top and bottom face. You have a nice surface finish, and you have the right start distance, which is should be 1/4 inch. Then you want to drill the center hole where the hex is. The EDM can touch the hex, but it cannot do the hole. So you need to do the hole for the EDM before you put it in the EDM. As long as you're, I set the hole to be 1/4 inch, but if you want to change anything smaller, be fine. Then we're gonna use the EDM to do the inside of the hex. Then we're gonna switch to the outside cut the gear path. Yeah, I'm not gonna go into the mill spray in this project because it should be quite simple. So how to use a spray to do this EDM thing? So first of all, you want to have your part and your stock import into Esprit. And also there is a Esprit template which will also provide for you guys. Then make sure the one thing you need to make sure is the part and stock is sitting the corners at the order. It's not the center. It's the corner. And yeah, I just made the bottom left to be the origin of the operation. And then you want to create a chain. You just you want to smash the part in the Esprit. Then make the tolerance like half of what we used to do. Then you make the chain of the inside and outside feature on the XY plane. Then you want to select chain. Then you want to select the solid wire guide, solid wire platinum in the Esprit section. You select contouring. Then you need to set all the distance, upper wire guide, the workpiece thickness, reference plane, the lower wire guide. Those are pretty much, because you're using wire DM, you have 2 things that hold the wire. So you need to set what the upper holder is and the lower holder is. The machine also need to know where your XY plane is, because that's where you do the operation, and how thick is the workpiece, so they can touch your workpiece. And one thing you need to know is for the outside profile is a punch and the inside is a die. So that's just something to select for the Esprit, that's why it came out wrong. Then in cut data, you need to select strategy and set EPAD to 2011 and register 1 for the set register as 1. So in this set, it's kind of like a laser cutter. You select how much power is going through and how many tool paths you're gonna do. So in EDM, you can have a rough and a skim. So rough is like the rough cut, you just want to cut the shape. Skim is like you want to have a surface. It's like a finishing cut, do surface finish. Then you need to set up the startup distance. So you don't want the wire to be sparking. The wire touch the piece then sparking, because that will just ground your wire. It doesn't work. So you want the spark to be sparking before you enter the whatever start you want to cut. And also you need to set the entrance exit position so the wire know when it's starting to do his wire EDM thing. That's it. Thank you very much. Any questions?
This would be a good time for the class to have questions.
Wire always have to stay vertical, or is it possible to set an angle?
It is actually possible to go for angle. So if something like a charging turbine or something, yeah, you can go at angle. But for this, we don't need to. So how it works, you have 2 XY plane. So you have 2 points, line. Yeah, that's how it works.
I missed it, but what material are you using for the gears?
We'll be using aluminum. I think it's 60, 61.
Somebody said steel. Somebody said aluminum.
It is
Oh, I'm sorry. I
aluminum.
was referring to like the hardness. Yeah, I guess currently we
Okay.
have a piece of like aluminum blank.
Okay, perfect.
So you sort of mentioned that there's a little bit of sparks. Is that something that like you can essentially account for, like you were doing, or you did like as if it was the radius of the essentially?
Yeah.
There's an assumed knowledge that like it is going to be like there's published information about what that is going to be. I think for your tool or at least your wire type. Yeah, so that's something that we'll be able to figure out, or you can also figure it out experimentally, right?
I actually had a comment. You have a typo on one of your slides. You had inches per second for the speed of the mini mill, and it's definitely inches per minute, not inches per second.
Right.
And so I know that it's 500 inches per minute on the mini mill. I don't know if it's 40 inches per minute on the EDM, but 40 inches per second sounds pretty fast. So I'm guessing that's also 40 inches per second is like what, this far?
Yeah, it doesn't really travel
This far?
That's
Yeah, it doesn't move that fast. It even moves that far in a minute? That's pretty high speed for them. I don't think you cut that fast.
This is max speed.
Yeah. And could you elaborate on why you pre-drill the hole?
because EDM wire cannot do the hole. So you need to pre-drill the hole to let the wire through the hole to do the inside circle.
Yeah, I knew the answer. I wanted you to share with the class.
So the wire EDM cannot drill the hole, and you need the hole to do the inside cut, so the wire can go through the piece.
So you thread the wire through the hole in order to do the inside cut.
Yeah, that's how it.
Any other questions? Has everybody figured out how to do the quizzes?
I'm actually
This
confused.
is group one.
But on the actual thing, it says like presentation hall.
Yeah. Was it a quality presentation? What's your judgment of? Oh, yes or no? Rate it on a 0 to 10 scale. Use a Likert scale for that if you haven't already answered it.
The correct answer is 10. I checked.
Can I ask a question about that since we haven't looked at the quiz yet? It's presented. So is the intent for the question, like, or if you ask a question, you're supposed to ask a question during someone's presentation? Is that the intent for that?
You should ask a question of each group in the quiz. The questions in the classroom are to foment discussion
Yeah, okay.
and to clear up anything that was unclear. But the idea is in the quiz that you've watched the presentation and you've thought of something that if you knew that answer, it would give you more information, which then the group could potentially respond to in the following week's presentation. Because you'll get copies of all the answers that everybody puts in about you, all the feedback. Does that make sense to everybody? Perfect. We are a little bit ahead of schedule, but let's keep plugging through if group 2 wants to get up there. I'm going to figure out. I'm gonna put my phone down. Anything over here? And you were several minutes into that presentation before I realized that I was still listening to it also on YouTube with about a 4-second delay. And it took me a few minutes to actually have that click in my mind. Go ahead. Full screen.
So we had injection molding. We didn't get too much in the way of finding out like what we needed for our machine because it was locked behind the door in Unity, but we did go and visit
But
it.
you found it.
We did find it, yes. So what is injection molding?
So injection molding is basically just taking melted plastic and forcing it into a mold that where the plastic then expands into the mold. You let it cool, you take the mold apart, then you have your part. So some of the basic stuff, some of the good advantages for this sort of thing is you can make some pretty small, pretty intricate parts, but it has some difficulty with the really, really small stuff and with sharp corners and filling up sharp corners. So with more rounded parts, it has a lot easier time. You can also make parts pretty fast with injection molding, but it's not the most accurate way of making parts.
And when you're designing the mold for your part, you need to keep in mind a lot of different considerations. So the material you want to use, the shape and the features of the part. In a basic injection molding mold, there's different parts that you need and are required. So you have the basic mold. Yeah. So it's.
We printed out an example mold if we want to pass it around.
But you need the mold itself, which is the light gray part, and the blue is the actual plastic part that you will be injecting the plastic into to make. You need to make sure that there's a hole in the top for your sprue, which will let the molten plastic in, gates to let the plastic into the parts, and then to remove the part from the mold, you need ejector pins. So if you look on the bottom of the bigger mold, there's 2 or 4 tiny holes. Those are for the ejector pins. And then when we just have our design for our part, so this is the first kind of idea, which was just kind of thrown together quickly based off the design from the other class. And so the gray is the mold.
Yeah, so we decided to, we started with this one. First we thought, we were just making one foot, but then we realized, we need 2. And looking at this, when we did some more research, we realized that this would take up a lot more material than necessary, and it had a lot of sharper corners near the edges that might be difficult for the injection molding to fill. So we then redesigned it the way that you can see in our 3D printed part. That's just a rounded design like that. So it'd be a lot easier for the injection molding to fill it, and it wouldn't use as much material, and then we can print both of them at once.
So are you guys expecting 4 holes to like hit those feet to be inserted into?
Yeah.
Yeah, we also weren't sure what your design was. Okay.
Okay.
I think it'd be hard to balance on 2 feet.
Yeah.
I think you're gonna need at least a 3rd hole.
Yeah. So ours right now uses for 4 holes and has 2 feet that goes.
This is why we have an early design meeting so that the different design groups can talk to each other and work those kinks out.
So
I have a few questions.
So you've got 2 pieces that are identical,
Yeah.
and you're just making 2 at once with 1 shot, right?
Yeah.
And so I think you put 2 holes at either end of the thing or something.
we want to put like 10 or something just so we can print out a bunch. Yeah.
A few questions. What's your material?
We're not sure yet because we haven't gotten in contact yet with the person that actually made
I can answer that
those.
question. There's a pallet with injection molding plastic beads that's on the floor in Washburn 108. That's your material. I don't know what it is, but you can go read the label.
Okay. So we got to figure that out.
What's your tolerance?
Tolerance.
Because you're gonna fit into their part,
So we're planning on making it about. We haven't yet figured out exactly how good the tolerancing is on this particular machine because we haven't yet gotten to actually interact with it or know much about it yet. We don't even know the model. So we got to figure that out. But we're planning on making the part about a 1/4 inch. So because we're hoping that, partially because we're rounding the top of these, we're hoping we'll be able to pressure fit it into their holes. Make theirs slightly smaller, so it'll be able to use a hammer or something like that to pressure fit it in.
I just technical question I forgot. I know if you mold with metal, it will shrink because the
Yeah.
It has the same problem.
I believe
Yeah,
so.
it
Yeah,
will
it does.
plastic.
It does have the same problem. So yeah, there is more.
Yeah, I just forgot about that.
So is there, on sort of a similar question, does it, how much does it matter what material the mold is made out of? Is that,
I'm guessing we're just going to be machining it out of aluminum, but the mold would affect it too, like the heat transfer of the mold. So if it absorbs more heat, then it'll need like a different pressure, or maybe these gates right there, those will have to be bigger or something. It will affect it, but I'm not 100% sure on that yet.
So for your gate design, did you do some research on that, or how did you come up with the parameters you picked just to start with?
This is just kind of a rough idea. I based it off of just like this kind of side thing. And I've had experience with rubber molds, and you put those in a centrifuge and you pour molten metal into that. So it kind of, from my experience with that.
Okay.
But yeah, we'll probably have to fix this in the future a little bit.
You mentioned ejector pins to remove the part. Have you guys taken into consideration any of like the draft that you might need to get the part out?
No.
Anybody else?
So I just don't know how an injection molding device or machine works. Would that part, like the metal parts, would those get like really hot? And would that be like a safety concern? Like, if you touch it, it's like burn yourself sort of thing.
And probably a little bit. You'd want to you put it in the vise underneath the plastic injector, pull the lever, probably let it sit for a little bit, and you can take it out.
So in production molding machines, they get very hot, so there are safety concerns there. They also you have to cool the plastic enough to take it out in order to do that. So they have cooling, so they'll have cooling lines in them and stuff like that to pull the heat out. Because the faster you can cool it, the faster you can make a new part.
Yeah.
Not as critical in our application.
What's the height?
The mold itself, I think, is 1.5 inches or 2 inches, like together, and then the part itself is
Inch, right?
it's 1 inch wide from center point to center point, and I think it's 0.75 inches tall. But that can be changed very easily. I just kind of put a random number in there because I still didn't know what your design was.
Yeah.
Anybody else? All right, group 3.
Just in a
You didn't even have one. Okay. There's nothing there yet.
So yeah, our project was to research kind of the 4-axis lathe and using that part, or group 3. So just kind of overview of the 4-axis lathe that's in Washburn. It is the Haas ST30 SSY. It is giant. It's probably almost from here to the door, full length, and it's a lot bigger than we really expected. The max cutting capacity is a 16-inch diameter and a 23-inch length. The spindle speed can go up to 4,500 RPM. The coolant tank is a 55-gallon tank that has a 0.5 horsepower pump, and it has a 10-inch hydraulic chuck. So just kind of some basic information. There are a lot more listed parameters on the model of it, but these are kind of the most relevant for us in the project, as we are just kind of machining a fairly simple part.
So the board itself, what we were given last class, we still have to figure out the left side, the end dimension of that based on the bearing that we have.
Right.
And then the center part of that hex piece that'll fit into both gears, that is 3/8 of an inch around. And then the other side of that is a 1/4-20 thread on one end. So relatively simple, but those are our kind of preliminary CAD model before we kind of finalize some of the dimensions.
So we didn't talk about this before. We plan on cutting it out of 1-inch diameter stock.
Okay.
So that'll be a lot of material removal, but it's the smallest stock that we can conveniently use with that chuck.
Okay. Good to know.
So our project objective is to manufacture a hex shaft on the 4-axis lathe that meets the required tolerance. We don't know which tolerances are yet. The tasks that we have to complete to do that are determine the part dimensions and create the sketch, confirm part dimensions, make sure it works with the other team's designs, get the stock and the tooling and parameters, create the part, and then lastly create the tutorial for the other teams to follow.
And so for our progress, for our current project progress, we have, well, that was when I wrote that a couple days ago, so that's not correct anymore. So we now have received the CAD design. With exact dimensions, yeah, we're still figuring that out. But yeah, mock-up has been created, like this is now. Obviously, the part has not yet been machined, and we do not yet have a program for this part creation, so probably going to need some assistance in coding the cut path parameters, because I think all of us are a little rusty when it comes to lathe operation.
Yeah, I think we should set a time to meet and work on that together. Today's Thursday, right?
Yeah.
I think I can actually be free most of tomorrow morning. I'm just double checking. So I'm free after 10 o'clock tomorrow morning until, well, I could figure out to be free all day. If somebody's got an appointment with me, it's 15 minutes, so we can take a break. So if some combination of you can meet with me tomorrow morning, we can go through some setup steps on the lathe and go through the programming that you're going to need to do for the mill turn.
And lastly, we completed some research on how we machine gear shafts. I incorrectly assumed that this would be closer to an actual gear teeth rather than a just regular hexagonal one. So I looked up gear hopping as in how gears are cut. And the hop is a type of cutting tool that they use to cut the teeth, mostly in cylindrical pieces, so it is a separate lathe attachment. And those hops can come in straight or spiral shapes. And the main difference is that, well, straight hops are like a cylinder with multiple completely perpendicular transverse rings of cutter teeth, and they have to be moved in and out individually to cut the teeth. So it's a slower process. Whereas spiral or helical hops consist of teeth wrapped around that cylindrical shaft, and those can be moved in and out continuously while spinning at the same time as the actual gear that you're making. So it's a faster process. And then as for shaft threading, you would have to worry about partial or full profile inserts to be able to cut the thread groove, either without or with topping and cresting those threads respectively. And then there are multiple in-feed pass methods to form those threads, being radial flank, modified flank, and alternating flank. And radial is simply where you put in the tool exactly perpendicular to the workpiece, which is probably the least recommended method, considering the lower quality of the thread you'll be forming. Flank is when you insert it at the desired angle of
the length between the crest and the groove, right? Probably 30 degrees. But it does have the problem of the trailing edge of your tool piece dragging along the flank. And so then there's modified flank where that angle is slightly less than 30 degrees, and you reduce that problem somewhat. And then there's alternating flank, which is what it sounds like, where you use both ends of the tool and approach the thread from both sides of it gradually, which improves tool life, but definitely has a problem when it comes to chip formation, because once you're forming it one way and then you're forming it the other way. So that can result in poor surface finish as well. And that's it.
So when looking at the picture of your design, I noticed that your hex cut is the same as our gear cut, which, I mean, it's fine, but how do you intend on holding that gear up? Because it looked like it would just slide
right over the shaft.
Yeah.
Yeah, I think you need to add a little lip that the piece slides down against, and then the top screw thing comes down and holds it against that. That was a good catch because I didn't notice it. But you just add that little bit there, there'll be plenty of material.
What's the purpose of the threading at the top? Like, are you attached to it?
Yeah, there's a knob that's going to screw on that'll hold down the gear so it doesn't fly off the top. We haven't determined who's making that yet. Maybe it'll be you guys. No, don't worry about it.
Forgive me if this is something you talked about and I just missed it, but how exactly does you're doing before that assembly layer? So how does that factor into the actual manufacturing of the piece?
We're not too sure. I'm guessing it's going to be with the hex cut because we just don't.
You're going to take round and make it hex.
Gotcha.
Yeah.
With a milling tool and noise.
I noticed there's no dimension on your drawing, so how long is the hex?
Well, that's what we did mention that. We have a mock-up, but we don't have all the exact dimensions yet.
Because we're just 4-inch thick, so if you're longer than a quarter,
Well, we were planning to coordinate with you guys.
Yeah.
Just make sure our dimensions do work with yours.
They said that during the presentation. I heard them.
Any other questions?
Anything else?
I know we don't know the bearing size or anything yet, but you know your tolerances will be.
Not yet. No.
Anybody else? All right. This is group 3, right? This is group 4. Yeah. That's a good question. Yeah, do an assessment for your group 2.
Okay. Isn't there like a separate assignment?
Yeah, but there's.
We also had a group 5 assignment, but
Yeah, just skip group 5. We had the possibility of having 5 groups, but we went with 4.
Hi. Hi everyone. We're the 4th Axis Milling Group. Yeah.
All right. What is the 4-axis milling? This way. Sorry. Yeah. So before I start explaining the 4-axis, I want to explain the 3 regular base axes, which the spindle has 3 linear axes, X, Y, and Z, as you see in the animation. And the X-axis, Y-axis, and Z-axis. When happened the 4-axis? Well, the 4-axis happened when you add in a rotational axis, which is the A-axis, as you see on there in the animation. That gives you the rotational movement to the specimen that you're going to be putting on the workpiece of the spindle, and give the spindle the ability to rotate about the Z-axis. Is this useful? Yes, it is, because this A-axis gives you a new angle approach for the for the mill tools, and also it's more economical. It's a more economical way of machining part, which means that instead of if you work in a project and you need to buy two different features, you actually buy one. You're saving some money saving money and time because you are cutting and rotating the expenses at the same time. So these four axes give you reduction of in the economical part and also timing part. But
So next, oh no! Yeah, so this is our rough plan for how we're going to start making our part. So Rodrigo is sort of our expert in the field in terms of how to actually make the fourth axis work. So we talked to him yesterday for a little bit, and we set up a more substantial appointment tomorrow to actually. He said he himself isn't exactly sure what state the fourth axis of the mill is in at the moment. So we're going to go in and, as a group, see what exactly is going on there, get the important details on how to work it, the sizings that we can use and all that stuff. Then we're going to work on a fixture plate, which essentially would mean attaching all of the important tools like the live center and the fourth axis to a plate that can easily be inserted and then removed from the machine. It's hard to see the drawing even though they like step back. It's essentially so you have to stop. This is basically starting right now. There's away from the stop. You have the this is sort of animation and out of there. So you have a long piece coming up. And so you essentially have your cutting tool coming as the piece is rotating in the shop. You can do it, and so it's essentially similar to a blade. And you put the tool in and you rotate it, and so you cuts it as it rotates. Yeah, there's a similar video there. I was guessing about the top operation. Right. Well, so the in the design, but those are flat faces, so those are pretty quick.
So with this part, what orientation is it going to be? Where's the jaws going to hold this piece?
Yes,
So go no on this piece, just like stand next to it and show me.
So the jaws are essentially coming in on the sides like that. So this you can essentially do an inner way with the out of the
Okay. Okay. Yeah, so you're still working on that, and you're going to change the design to incorporate feet at both end anyway. Okay. Yep. So if somebody can come by when I'm meeting with them tomorrow, I can give you a handful of bearings and we can work on that. We'll do all that at the same time. The spacing between your two bearing holes, how do you know? But it depends on how far the gears need to be apart from each other. So you don't know that number without interacting with the people that are making the gears and know what the circle is. So you don't know. So you should interact with group one to figure out what that spacing needs to be based on the gears that they're making and how far apart they need to be from each other. Any other questions? All right. Looks like we're going to end a little bit early today, so we could go do the bearing stuff right now. I mean, right now, as soon as we walk out of the classroom. All right. Thank you, everybody. I can take it. I think you should tell them the specification for how far apart the things need to be, rather than make them do the math themselves, right? So yeah, you could just, here's our design, you guys figure it out, but that's not in the spirit of making it go faster, I think. So and I think that, and this is one of the things that especially engineering groups have to do and normally it would be on like a bigger project. Like you're designing the next space shuttle, not that you're designing a little widget thing. But it's these kind of conversations where if you get all the different designers in the room together to talk about their progress and what they're doing, these questions come up, right? It's the question that, like your first question, how many feet is it going to have? Because we only had we only had 2 holes, and I had envisioned what they did. But it's that's the whole thing, is being able to be a good engineer and design stuff well is important. But if you can't communicate that to the other people, it's going to be wasted. And you're not going to do much as engineers. And I do think that one of the best things WPI does is prepare engineers to also be able to talk to each other. And sometimes even talk to non-engineers. Kind of cool. And so on that topic, I have some general feedback for everybody. And then I'll give each group some specific feedback in the on Canvas and everything. But when I was a WPI student, it was really the first time that I ever was in a position where I was doing presentations and stuff just like this, right? Yep. We could. So I'm in several Slack chats, and I'm not very adept at it. So I find that I only get alerts when messages come in if it's the last one that I had opened up on my device. And so with that knowledge, I don't think it would be horrible to do it. But if you need me to respond to something, send me a text that says, go look at the Slack or something like that, right? That's all I'm saying is I'm not very good at Slack. And I do keep one of them open most of the time. So I'm only getting notices from that one. But yeah, that could be a thing if you guys want to do that. Or just, there's a email alias for each group, right? Is there any group that has not created an email alias? Okay, so I'll reply all to all the email aliases and pass those around, and then if you or I'll make a list. So if you want to talk to group one or something, you can just email that alias, get the response back. It's probably simpler than creating a Slack. Anyway, what I was going to say is I actually took a course on giving presentations when I was a WPI student. I had to. It was a requirement for something else I was doing. And there's a few things that we learned. And so this is general feedback for everybody. And it's not something that I would be taking points off. It's not something I'm judging you for today. But after we do our first presentation, and I give you this feedback, I will judge you on it in the future. How's that? More pictures, fewer words on the slides. If you have a complex thing that you're trying to describe, talking through the explanation is really hard, especially when you're talking to other engineers. Engineers all tend to be visual thinkers. And so pictures work better for us for doing explanations. It's okay to be a little bit dynamic and point the stuff on the slides and things like that in front of the group. I suppose unless you're on crutches, then maybe you should keep the motion down. By the way, applause for getting up on crutches to do the presentation after I said you didn't have to. So in general, I think that if we have one or two people doing the presentation for the group, it doesn't have to be every person each class, as long as each person participates in one of those throughout the term. It may make it go more seamless. It may seem a little bit more present-y-like. Usually you don't have the whole team stand up and do a presentation to the group, but one person will review what the team's been going over. Dress as if you care about your audience. And I know we all go to school with our dressed how we dress, but that was one of the things that I was taught in the presentation class that I took was, dress up a little bit if you're the presenter. Look nice if you're the presenter. And it shows the people in the audience that you respect them, that you put some thought into it and you cared. There was nobody with slippers on this. That was good. I've seen that before. Pajama pants and slippers to do the presentation, the final presentation for the grade of the class. And so, these informal working group kind of presentations, I wouldn't worry too much about it, but certainly in the final presentation, whoever's going to stand up there should dress as if they cared about impressing the people they're talking to. So that's my general feedback. I think in general, we got some discussion going, right? So what are the key things that the groups need to communicate on right now is tolerances and locations where the parts interact with each other. Right. And so like the spacing of the holes on your part is determined by this group. The depth of that hole and the size of it is going to be determined by the bearings that we're going to use, and we're going to walk over to the lab right now and get those. What else came up? The length of the shaft is going to be determined by the thickness of the bearing, how much needs to go in to the bearing, the gear, and the threaded thing on top. And I think so. Yeah, so it's going to depend on the bearing, the thickness of the gear, and the cap that we decide to use. And we'll pick a cap out of a catalog. We'll buy that. Yep. Or the email alias for your group. You could do that. Yeah, for each group, we could do that. We could do that right now. Everybody could. One representative that knows the email alias can write it on the board. And before we end today, let's find a time that we're going to meet to go over the late stuff. Anything else? Any other group stuff that's going on? Any other group interaction that needs to happen right now while we're all sitting in a room? We'll find stock for you. Yeah, don't worry about it. If you need something that we don't have, let us know. We'll figure it out. Yeah. Yeah, I'll do that. And so each group got feedback from each person in the class, presumably, about their presentation and about their questions. And so one of the things we're going to do today and tomorrow is collate all that and get it back to you so that you can see that feedback before you do the next presentation, right? Yes, I think that's it. I think we're good for today, but it would be good if we capture all the group email aliases, and we'll set that up later. Let me just go ahead and stop there. Share.